Good day, my learners. We are here again. I welcome you for another topic in mathematics, where we made the other time. This is another period for us to have another topic that is very interesting, and it is for everyday life that you always use in your own day-to-day activities. And the simple topic is probability. Probability, as we all know, is the possibility of an event to happen or not to happen. It means it involves every activity, every event that happens each moment of your life. At times you do what is all about probability, you will not know that you are playing probability. So probability, as I have said, is all about the possibility of an event to happen or not to happen. Or we can equally say it is a measure of the likelihood of a required event happening. So whatever that happens in everybody's life is all about probability. Now, in mathematical terms, we can define it this way. Probability is the required outcome all over the possible outcome. So what you expect to happen, what you are expecting to happen, will be all over what should have happened. It may not happen completely, but partially. But you find out that the value of probability ranges from 0 to 1. In anything you are doing pertains probability. You always get either 0 or any values between 0 and 1, or you get 1. If the event will never happen, then your probability will definitely be 0. If it will definitely happen, then your probability value will be 1. But if it is partially, then it will be a number greater than 0 or less than 1. If it is partially, it will be either greater than 0 or less than 1, where you will now have it as 0 less than x, x less than 1. It means that the value of the probability that has happened will be x, where if it is not definite, then it will be less than 1. If it will never happen, then it will be 0. If it will definitely happen completely, then it will be 1. So that is why I have given the range that it will be between 0 and 1. It means that if the value of the probability is less than 0, then there is something happening. It must be a negative value. So if any time you are calculating your probability and your answer is less than 0, or you get a negative number, then it will range from minus 1/4, minus 1/2, on and on, or minus 1,000. So people may calculate and get minus 1,000. Definitely you know that you are wrong already. So because there will be no how, you will not get any negative value for your probability. Again, if your probability is greater than 1, then you should also know that your calculation is wrong, or you interpreted your probability wrongly. So it must be either 0, greater than 0, 1, or less than 1. That is the range of your values of probability. So for our level at this time, we know that probability will have many types of the probability. But our own secondary level, we have 2 types of probability, where there are experimental probability and theoretical probability. But in our own level, as JS class, we are going to depend on the experimental type where we are going to participate in doing it ourselves. We will participate in doing some of the things and we get the results. We will not do it just theoretical without seeing some things that are happening. So we have to do it practically. So that is why we are depending on what? Experimental probability. This is a probability that depends on demonstration of the happenings. So in probability, we have so many events. In games, in activities, in class. So let's have a game. We have a game known as Ludo. We call it Ludo. Right? And we call the object that is used for the Ludo as dice. This is the dice. And this dice you are seeing, it has, let's count it together. It has many faces and we are going to discover it together. This is 1, 2, 3, 4, 5, 6. So we have 6 faces in a dice. Now, if you are in an exam, they can ask you a question. They will say, what is the probability of throwing a dice? And it is 1. Like this one now, I will throw it. You will throw it anyhow, and then it lands. And the face that is up, what I'm seeing here, I believe you people are also seeing. I can see, count the marks on the face that you are seeing. The face I'm seeing is, we have 1, 2, 3, 4, 5 marks. So the probability I'm seeing that has, after my throwing of the dice, is 5. So you know that in probability of using dice, which is the Ludo that we call it, we have the faces as phase 1, phase 2, phase 3, phase 4, phase 5, and phase 6. So if you have these 6 phases, the outcome now, the required outcome, particularly for the one we threw now, we just threw now, the outcome is that press, which is 1 out of the 6 phases. The phase you are having is the required outcome. And then the possible outcomes are the whole phases of this particular dice we are having. And we said we have 6 phases. So it means that for the one that we saw that we threw, we got 5. And we have only 1 5 in these phases. Each of the phases has 1. 1 has 1, 2 has 1, 3 has 1, 4 has 1, like that. So now that we got 5, then it means that our probability of throwing a dice and the first is 5 will be 1 over 6. Because that 5 we got is 1 out of the 6 phases we have. So it means that this one now is the required outcome. All over the possible outcome, which is the 6 phases of the dice, we have our possible outcome. So if you now have this one, it is already in a proper fraction. It is already in a proper fraction. So there is no need for you to maybe reduce it to its simplest form. Or the only way you write this one is to write it in its decimal form. Where you now have, this one in decimal form will give you this way. 1 divided by 6. Which you have 0 point, you add 0 to this one, you will have 10. 10 divided by 6, you are going to have 1. 1 times 6 will have 6. Subtract this one, you are going to have 4. 4 divided by 6, it cannot, so you have 0. Already we have decimal, so we cannot put any decimal. You keep adding 0 to it. So this one becomes 40. 40 divided by 6, how many times? You are going to have 6 times. 6 times 6, you have 36. you keep on getting 6, 6 like that continuously. So you have 3 dots. It means that the 6 will continue. And remember, in our JS2, we talk about recurring decimal. The decimal that can never end. So if you have a problem like that one, what you will do is, our answer in one, you can now shorten the number that is recurring on and on like that. It shows that the 6 will keep on repeating decimal. So you now have 0.16, then you put dot on top of the 6. It shows that that 6 keeps repeating. Whether you continue till you die, you will not finish writing the 6. So you just write it in short form. You have 6 dots. It shows that 6 will keep repeating. So to shorten it, you just put dot on top. Okay? So that is that about. That is one of the events. So we are going to see others. So we said we'll have other one with this same thing. You will be asked so many questions on this one issue. So as we have seen that of 5, that the probability of getting 5 when we were throwing this dice is 1/6. We calculated and we got 1/6. Or we can have it as 0.16 dot, where we said 6 dot shows that 6 keep repeating. Now, what if the one we threw and we got 6 as the face? If we got 6, then it will be, how many 6? We know that we have only 1 6 out of the 6 faces. So it means that our required outcome is equal to 6, which is 1. Then our possible outcome which is how many faces? We have 6. So therefore our probability of getting a 6 will be equal to 1/6, which will be the same answer we got for getting 5. That is our B. This is our B now. Our C, for 3, you know that we only have 1 3 on the face. So it will also, probability of getting 3 will be the same thing as 1/6. We have D, probability of getting 4 is also 1/6. We have probability, our E, probability of getting 2. We also have only 1 2 on that face. So we have still 1/6. And then we have F, the probability of getting 1 is equal to 1/6. So any of the faces, they have the same probability. There's no change. Since it's only 1 dice we use. But in your senior class, you will come and see how you use 2 of them at the same time. But for our own level, let's understand this one first. So if it's only 1, you throw it once and you now calculate the probability. Then we have another event which we call what? Many of you, I know you have been playing this one during this pandemic. You have been playing what? And this word, it has 54 cards inside with different shapes. And some of you might have even, I know some of you are recalling the shapes that are inside. Okay? So, and the probability of the event of any of these games, this one is another game. So when you have about 54 of them, where you have the first one here you are seeing is 20, And you know what the 20 can do when you are playing it. And another shape is square. You know what, when you play, there are values written on each of the cards. And there's another one, we have circle. Another one, we have star. Another one, we have triangle, like that. All of them. But they are not in equal number. They are not in equal number. If you want to know how many per each, this one, 20, they are 5 in number. They are 5 in number. Okay? Then the cross. We have a cross. The cross, they are also 9. These ones, they are cross. They are 9 in number. Then we have what we call star, of which I know all of you have known about it. We call star. These are the star. This is the shape of the star. All of them there, they are 7 in number. And then we have the circle that I showed you before. The circle, they are 12 in number. The square, they are 9 in number. The triangle, they are 12 also in number. When you add all those numbers, you are going to get 54 cards. Okay? So now these 54 cards, you know you used to pick one, you pick like that. They will ask you to pick 2, they will ask you to pick 1, they will ask you to wait. All those games is mathematical. All those games, they are mathematical. So now, the cards that I've shown to you, I may hold it like this, and I can ask one of you to pick it. So now that we know that the 20, we have 5 of them, okay? The 20, we have 5 of them. The cross, sorry, the cross, which is with this sign, we have 9 of them, okay? Then the star. The star, we have 7 of them. We have the circle. The circle, we have 12 of them in number. We have the square. We have the triangle. This is 9, this is also 12. If you add these numbers, you are going to have 54 cards. Okay? Now, when you are calculating the probability of picking any one of these cards, they will ask you this question. When playing a card, the word cards, what will be the probability of picking a card, one card? That it is a 20, that it is a cross, that it is a star, circle, square, and triangle. Any one of them can be picked. They are liable to be picked. So I can hold it like this. Let me pick one. Let's see which one among them we are picking. I'm picking any one from the pack. This pack, we call it a deck of cards, or you can call it a pack of cards. So I'm picking only one from out of the pack, just at random. I've picked one. See what I've picked. The one I've picked is a square. And how many squares did we say they are all in the pack? We have 9 of them. Right? We have 9 of them. Now, for this issue to be calculated, you now say the required outcome is the total number of the square, which is 9. You are not going to say 1, no. It's the total number of that group that you are going to pick as your required outcome. Then your possible outcome. How many of the cards did I say all in the pack? How many of them? I can hear some of you are saying 54. So there are 54. So the possible outcome is 54. Now, The probability of picking a card that it is a square now will be the probability of picking a card that it is a square will be 9 all over the whole number of 54 cards. That is the probability of picking a card that it is a square. I have picked one and you saw that it is a square. Okay? So it will be 9 over 54. Now, this answer now, you will know definitely this answer is less than 1 when you calculate it. 9 over 54 is a proper fraction, so it is less than 1, it's 0 point something. But in the 9 and 54, if there's a common factor between the two of them, then you can now use each one to divide by that common factor to get a simple, proper fraction. Is that clear? I hope you are hearing me now. So don't make mistake. Some of you may say you're going to have 54 over 9. It's wrong. That is where I said maybe you misinterpreted your probability. But if you interpreted it well, we pick a card, and the card we pick is a square. And you should know that it is the number of the square totally in that card or in that pack over the whole pack, which is containing 54 cards. So don't make mistake that you say 54 over 9. You are going to get a number more than 1, which is totally wrong. Or some of you might, I don't know, you may manipulate how and get a negative number, which is also wrong. So always learn to interpret your probability questions properly. When you get 1, you should at least have confidence that you are learning at a better option. When you have 0, you are learning at a better option. When you have less than, greater than 0, not more than 1, you are learning at a better ground. But if you are having a negative value or a number greater than 1, then you know you are on your own. Nobody. So this one we have 9 over 54. What if I pick another one? I will return this one I picked back to the pack. I will return it back to the pack. And I pick another one. I don't know which one I will pick. So wait and see what will happen. Can you see? What I picked is a star. What I picked is a star. And then we said, how many stars do we have? We have 7 of them. Total number of stars there is 7. So our required outcome is equal to 7. Then our possible outcome now. What did I say? The whole of the pack contains how many cards? We have 54. So the probability of picking a star now is equal to the total number of stars all over the total number of cards inside the pack. So we have 7 all over 54. And this is your result. You may decide to get your answer in decimal like I did for that of 5. You can do the same thing. Okay? So that is that, and we have so many, we have several. We are going to see another one again. Another. I thought we have many other events. This is another event. This is another issue. We call this one counting sticks. Counting sticks. And you can see that they will have several colors. I can see red, I can see yellow, I can see blue. Right? So these colors, we can also, this is a pack of a counting stick. So in this pack we have 50 counting sticks inside this pack. But let's discover which one is how many. We are going to discover it together. Okay? We're going to count them together. Now we have blues. Let's pick blues first and count. So these are the blues. So we are going to count all of them and see how many of them are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 blues. So we have blues. 14 in number. So we are going to return it back to the pack. Then let's pick yellow. Let's pick yellow and count. So we have 1, 2, 3, 4, 5, 6. Sorry, my girls. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 of them. So let's put them back to the pack. The ones who have counted. Then the red colors. Some of you may be asking for green. No green in this one. So it's only 3 colors. So let's count this one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. The one that has fallen down is among the counted one. 23. So we have red. 23. If you add this one, you're supposed to get 50 cards. You're supposed to get 50 cards, as I told you. Now, they can ask you the probability of picking any one of them. They can ask you the probability of picking any one of them inside this pack. So what is the probability of picking one counting stick from this pack? So I will close my eyes. I don't want to see which one I will pick, so that I will pick it at random. I'm not supposed to choose, but to pick it at random. So let me close my eyes. So I will pick any one. I don't know which one I'm picking. Okay. The one I picked is red. So how many red did we say? There are 23 in number. So the required outcome is 23. Required outcome is equal to 23. And then the possible outcome is equal to, how many cards did I say? When you added this one, you're supposed to have 50 of them. So it will be 50. So now, we'll now say probability of picking red counting stick is equal to the required outcome, which is 23, and then the possible outcome, which is 50. So you have 23 over 50 is our probability of picking a red counting stick. It's the same thing with others. When you pick another color, assuming you pick and it is yellow, assuming you pick it is red yellow, what you will now do is your required outcome will be now, if it's yellow, will be what is our number of yellow? We have 13. And then possible outcome is equal to 50. So our probability of picking yellow is equal to 13 all over 50. And you should always remember, I've told you, that when there is a common, assuming this 13 and 50, they have common factor. Assuming I got maybe this one is 12 over 50. Then you can see that 12 and 50, they have something in common. So I can now use that common factor to reduce it to a simple or proper fraction. So now this one, we have 2 is common between them. So 2 into 12, we are going to have 6. All over 2 into 50, we are going to have 25. Now 6 and 25, now there's nothing common between them. Okay? But 13 and 50, there's nothing common between them. 50 is an even number, while 13 is a prime or odd number. So there's nothing common between, no common factor between them. I hope you are hearing that. So where there is no common factor, you leave it as it is, or you write it in its decimal form. What that means that you are going to say 13 divided by 50 in your long division, as I did for 5 before. Right? That is what you will do. But if you leave it this way, you are also correct. No cause for alarm. You are going to get your full mark. Again, we have another event here. We call this one probability rolling kit. We call it what? Probability rolling kit. And this one, we have 2 of them that can roll. We can't use 2 of them now. This one is for our senior class. When we reach there, we'll see how to use them at the same time. But for now, we're going to use only 1 of them. Okay, this one is the rolling bar. Okay? The rolling bar has faces like that of dice. This one is phase 2, the phase that has 2. This one is the phase that has 3. This one is the phase that has 4. This one is the phase that has 5. This one is the phase that has 6. And this one has 1. Right? So, for this one, they can ask you the probability of rolling a rolling kit, and the phase that has been shown will be 5. It's the same thing like that of dice. Is that clear? So like this one that we are using, if this one moves, no problem. Don't pay your attention on this one because you are not using it. You can use them at the same time. When it rolls, don't count it as anything. We are using only 1 of them. So now, if you want to pick a probability of any of the phases, then we have to roll. When you roll it, you allow it to stop by itself. Is that clear? So now, this is what I will do now. 1, 2, go. The phase that has stand clearly is this one. And the phase is what? 2. Now, what is the probability of rolling and you get 2? Right? We know that it has 6 faces like that of dice. So it means the probability of getting 2 on a rolling kit, the probability of getting 2 on a probability rolling kit is equal to 1 over 6. It's the same thing as 1 over 6, like that of dice. Let's roll again. Maybe we'll get another different phase. Okay? 1, 2, go. it's still the 2 we are getting. But at times we get 6, we get 5 like that. So it is still the 2 we are getting. So the probability is what? 1 over 6. Remain the same thing. But if assuming we got 1 like this, then it would be 1 over 6. If we get maybe 6 like this, then it would be 1 over 6, continuously like that. Now, I have told you that so many events. Let's assume in our class now. I want to take our class now. We're in JS3. Now in JS3, we have JS3A, we have JS3B, we have JS3C. Now, if we have JS3A, B, and C like that, then we can have our class JS3A. We have maybe 30 students. JS3B, we have maybe another, let's say 29 students. Our JS3C, we have 31 students. Now, let's add this number of students in our class now. We are all in JS3, we have 10, 0, and 1. We have 4 plus 2. We have 6 plus 2, we have 9. We are 90 in our class, right? Now they can ask us this question. They will say, what is the probability of getting or picking a student in JS3 and the student is in JS3A? What is the probability of picking a student in JS3 and the student picked is in JS3A? For us to calculate that is, we will now say the required outcome is the total number of the students in JS3A, so which we have 30. Then the possible outcome is the entire number of students in JS3. How many are we? We are 90. So the probability of getting a student that is JS3A is equal to 30 all over 90. 30 all over 90. Where you can now reduce, I told you if you have a common factor you reduce. Right? In our primary school, they told us when we have 0, 0 and 0 will go. Right? When we are left with 3 over 9. We still have a common factor. 3 and 9, they have common factor. What is that? Good. I can hear some people are saying 3 is common between 3 and 9. So therefore, we will now say 3 divided by 3, we are going to have 1. 9 divided by 3, we are going to have what? 9 divided by 3. 2. So we have 3. Okay? So it means our probability of picking a student from JS3 out of the JS3 students is 1 over 3. You are finished. Right? You can also if the student pick is from B, you have 29 over 90. If the student pick is from C, you have 39 over 90. You are finished. If they have common thing between them, you do as I did for this one. If there is no common factor, you leave it as it is, or you write the answer in decimal form. And make sure your answer is not more than 1 or less than 0. If you did not pick any student, then the answer will definitely be 0. If you pick all of them, the answer will be 1, because we are going to get 90 over 90. Is that clear? So if you pick all the JS3 students and ask them to do something for you, you have picked all of them. So it will be 90 divided by 90, which will give you one whole number. And I told you from the beginning that every probability, if it will definitely happen, is 1. If it will never happen, is 0. And you have seen the ranges from 0 to 1. You have done so many of them, you have seen them. So I will give you assignment to solve particularly on this topic. So as you have seen all the examples of probability that we have done that of dice, we have done that of counting sticks, we have done the rolling kits, we have also done that of cards. You have seen how we calculated them. So I want you to use this particular example, compare it with what we have done, and see. And the question goes like this. In a class of JS3, there are 100 students. 5 have head ties, 30 have socks, 25 have school shoes, 10 have cardigans, 12 have games wear, 18 have eyeglasses. Use the information to find the value of the following probabilities. What is the probability of those wearing A, head ties, B, school shoes, C, games wear, and D, cardigan?